So this will be the build video for the Mind's Eye Mars Rover. One of the things you'll have with your kit is a packing checklist. So the packing checklist will show all of the sub-kits that are in there. It's double-sided. And then the inventory sheet will list all of the parts that are in the sub-kits. So when you open it up, all of these bags and boxes will be checked off for what you're included in your kit. And that way you'll be able to double check your inventory before you start building. As with all the Mind's Eye kits, first couple of pages, product safety information. Don't put the batteries in your mouth, put it on fire, things like that. Make sure your hair is up and out of the way, any moving parts, you don't want to pinch your fingers, things like that. This one, not so much worried about the safety glasses versus like the quadcopters. Warranty, terms and conditions, shipping and defective error product stuff, all the patent information. We're going to cover mechanical build and assembly, and then in the next video we'll do the microcontroller programming and radio controller setup. We do operation and then our dashboard interface stuff. So we have different connectors, 1.5s, 2s, and 3s. These all lock rotation, and then we have panel lock, 2 rotate and 3 rotate. These allow rotation. Connectors assemble together. You slide the core into the body of it. It snaps together. You want to make sure that the little pin on the edge is lined up with the slot, not with the body. And then if you hold the body of the connector, when you press it in, it allows this end to collapse, and then you can assemble the connectors. And when you push that in, it prevents the body from collapsing and won't let it come apart. So your kit will include a bag with all of the electronics. It'll include a power module, some Velcro, the flight controller, the GPS, telemetry radios, the extension for the telemetry radios. This will include your ping sensors, the cables, and then the screws for the ping sensors. You'll also have a bag that has transitions, the dual transitions, locking and rotating 2s, panel locks, 1.5s, 3 rotates and locks, and the cores for those, the threaded adapters, and the interference threaded adapters. You'll have another bag that will have all your beams. So various lengths and sizes of all the beams, 15s and on. We'll open these as we use them and go through, try to organize it as best as we can. You have a bag with 16 of the support arms. You have 2 of the normal differentials, so single inputs. They also have the solid spool in here. We will not use this for the kit, we'll use the actual differential. And then you will also have what's called a dual output differential. So this has an input and an output, and then 2 sets of the gears to have the input and output. We'll have a bag with the drive lines. You have your 8-length drive lines, a 3, 2 1s, and a yoke-to-yoke. You'll have your rack and pinion steering kits. So there'll be 2 of each of the pieces, 2 sets of each of the stuff for the steering. And then your wheel end kit. So this will have 2 sets of the steering wheel ends, and then 1 set of the straight wheel ends. Your wheel nuts, axle shafts, and all the hardware bearings. You have 1 motor by itself to go along with the motor case and gearing. And then you'll have a pre-built motor case that has the encoder on it. So this will all be assembled for you, adjusted the gear ratios and everything, so that you don't have to mess with the fiddly bit inside of the encoder. You have 3 sets of shocks that are pre-set up, and then all the hardware that goes with them. And then I've kind of cheated and I've put together a bunch of connectors ahead of time so that I don't have to have half an hour of filming putting connectors together. So one of the first things that we do is we're going to build the motor case. There are videos available, so if you go to mindseducation.com, you can see videos for motor case assembly, gear ratio adjustments. Then we get into the differential assembly, same thing. There's a build video for each of these individual components as well. So I'm going to grab the motor case parts and tools. And then I suggest using scissors to open the parts. It is much safer than a box knife or an X-Acto knife. And for this kit, we will set aside these battery loops. We don't use these in this kit. So it says to press the two bearings in. It should pop in pretty easily. And then with those in, we'll go to the next page. And then we're going to take our motor shaft, our spur gear, and then we're going to look for the 440 nuts and the 3/8 screws. So in the bag you'll have 3/4 screws and 3/8 screws, and then we'll have the motor screws itself. So we want 3 of these screws. We do pack extras in there, so you only need 3 of them, but there is going to be 4 in the bag. That way if you drop one or lose one, you won't be out of luck. So with this, it might be hard to see. There's a picture here showing which direction you need to put the gear on. So you'll want to put the gear on the side that has the longer shaft. So it'll slide onto there, and then that will put the gear in the center of the shaft, not on the back side. And then we just want to make sure we can line up the holes in the gear with the holes in the motor shaft. Put those through. And I like to start it so that the nut doesn't fall off, and then I'll put all 3 of them in place. And then once they're in place, then I'll use the flat wrench on the nut to tighten it down. And you want it snug, but you don't really have to reef on it. There's not going to be a whole lot of torque on these. The shear force of the screw will be more than enough to hold it together. So then we'll set that aside. And then this, it's going to say to put it into the back side. So you want to make sure that you're using the right side of the case. It'll slide into there. And then we're going to open up our motor. And then we're going to get our pinion gear here. And we're going to use the 1.5 millimeter Allen key. And we're going to make sure that the set screw is backed out enough out of the hole so that you can put the shaft of the motor through there. And you want to make sure that you align the set screw with the flat spot on the motor, and then you're going to mount the pinion flush to the end of the motor shaft. So set screw is flush with that, and then you can actually just barely snug it down so that it lines up but slides on the motor shaft. And then you want to align the end of the motor flush with the gear itself. And if you want to, you can also use Loctite on that set screw as well. For most of the schools, you don't generally need to use Loctite because it'll be taken apart and put back together pretty regularly. So with that set, we're going to go for the M3 by 6 millimeter screws. There's 2 of those and 2 of the washers. So as we said before, there's 3 in the bag. That would give you an extra one in case you lose one. And then 2 of the large washers. And with most of this hardware stuff, this should be a 1-to-1 scale for the pictures. So large washer, picture matches. And then we don't want to tighten these down, but we want to make sure that they're engaged with the motor. So I like to hold the screw through, place it through the hole, and then you can use the motor and set it down in place. You don't need it to be super tight, just enough to not fall back out. And then same thing with the other screw. Align it, thread it in just enough so that it's able to be moved. So then this is where if you had this gear on the wrong side of the motor shaft, the teeth wouldn't line up very flush. You'd have it offset one way or the other, and then you'd be wearing half of a tooth instead of the whole face of a tooth. So this is where we can take the other half of the motor case and align it. And they will key together with the little posts and the holes. And that will hold the two together. And we're gonna get the 4 3/4 inch screws, 4 40 nuts, and 4 washers. And then we'll put a washer under each head of the screw, feed that into the motor case, and then we'll take a nut, and we're going to put that in the back side. And you want to make sure that the flat spot aligns, and the nut should lock into that. So as you tighten the screw down, it's going to engage the nut and pull it down into place, and lock that into place. And then just repeat that on the other 3 corners. And again, since we're using nylock nuts, you don't have to really reef these screws down. You can just tighten it down until it stops, and that'll hold it together well enough. So then we're going to adjust the motor screws until the gears mesh and tighten. So perfect, tiny little bit of space, about the thickness of a piece of paper. Too much space, not good. Too little space, not good. Too little space is better than not enough space, but this will be tight and it'll prematurely wear the gears, whereas just the right amount of space is going to get your best surface contact. So the motor will rotate. So what you want to do is make sure you can look through the little window here, and then you can reach your screwdriver in and tighten the screws down while that gear mesh is at the appropriate mesh. If you wanted to as well, before you put the screws in, you could put a piece of paper in there, squish it down, and kind of look at how thick that space is, roll the piece of paper out, and then screw the case together. Tighten the screws down. So you should be able to have a tiny bit of back and forth and then be able to rotate it smoothly by hand. You don't want to hear any crunching or binding noise, anything like that. If it gets too tight or hard to do, then you want to adjust that gear ratio. Then we'll set that aside, and then we'll grab one of our differentials. So the differential bag will have two different sizes of bearings, the washers, nuts, and screws, locking differential that we won't use, and then it'll have the differential parts and the housings and the cases. So we're going to start off with all the differential pieces. So they'll be in two separate little bags. You have your ring and pinion gear, your carrier with its screws, as well as the spider gears and output gear shafts. There'll also be a carrier shaft in here, this little pin. That will go through the center of the gears across. You will have little spacers here, like bushings, but we found most of the time you don't need the bushings. The differentials are usually pretty well set up from the factory. So this will use a Phillips screwdriver for the little screws for the carrier. So you're going to want to take one of the output gears and not mix it up with the pinion gear. The output gears are the shorter ones. Drop that into the case. And then in the case, you'll have a little slot on either side, and that's where this shaft keys into. So then I like to take the spider gears, put them on that shaft, and then you can kind of pinch it and then align it with that slot in there and drop it down in. And then take the other gear, set it on top of that. And then you can take your ring gear, and you've got 4 screw holes that match up, and line it up, pop it into place, and then you may have to look down into there to make sure that they're aligned, and then put the 4 screws into place. And you want to be careful with these screws. Make sure you're pressing into the screwdriver with it. They are tiny little screws, but again, you don't have to reef it real tight. You just want to make sure that it's as close to flush with this surface as you can. If you feel like you're stripping it out, maybe get some help. So then when it's done, you should be able to rotate the output shafts smoothly. So when you rotate one, the other side will rotate opposite. So then we will grab our bearings. And one of our case halves. Slide both of the smaller bearings on the pinion gear, and then press the larger bearing into the case halves. And then our pinion gear and our ring gear mate together. And so we want to make sure that we know which side our ring gear is on. So you can like mark the edge of the case like it says. We're also going to put the head of the screws on that side of the case. Before you get the drive lines on there, you can kind of tell because the one side will have a metal collar for the bearing and the other side will have a plastic collar for the bearing. So if you forget to mark them or you don't remember if you put them on the right side, you can still see the metal side is the ring gear and the plastic side is not. So we'll put the two halves of those together. Make sure that the bearing's pressed in smooth, everything can rotate. And then we can set our pinion gear in there. And you'll have one bearing on the inside and one bearing on the outside. And then we will screw the case together. Washer under the head of the screw, and then we're going to put the head of the screw on the side with the ring gear so we can see the little metal side in there, head of the screw on that side. And I like to start both of these nylock nuts on there before I tighten one of them down. And then use the flat wrench. And again, you don't have to reef it down, it's just there to hold the two halves of the case together. The nylock part will hold the screw in there and keep it from coming out. And then you want to make sure that that output shaft spins nicely. If you get any weird binding, make sure that your bearings are pressed in all the way. That way, the heads of the screws on the ring gear are screwed all the way in. They might be touching the gears, but you'll want a smooth rotation the whole time. And then we'll do the same thing over again for the other differential. Put one of the output gears in. Gonna grab the two spider gears, put it on the shaft. Find the little notch in there, align that. Other spider gear in. Make sure that the holes line up with the holes on the pinion gear or ring gear. Looks like I'm missing a screw. That's a factory sealed part. All right, well.
You go grab one?
We won't need it really, but I was also thinking of just fast forwarding through the second one of these because it's the same thing as the first one. Make sure the metal part or the ring gear is where the head of the screw is going through. And now we have both of those done. We will build the center differential. So the center differential will build pretty much the same, except for instead of having one pinion gear, you'll have two pinion gears. So you have an input and an output. So you have an extra set of the small bearings. So you'll have two of these bags with the ring and pinion gears. One of them will just have you'll have an extra ring and pinion gear, but you'll want the extra carrier and ring gear. You want the extra pinion gear for the next steps. So same as before, you want to make sure that you're not using the longer one for the pinion. And you'll drop one of the output shafts into the carrier. Take the pin, put it through both of the spider gears. Align it with the slot in there. Put the other output gear in. And then align the holes in the carrier with the holes in the ring gear. So this is where we will want to get the other pinion gear out of here for this next step. We'll get the 4 small bearings and the 2 large bearings out. And we can press in the bearings into the dual differential case halves. You want to make sure that they're seated flush with the case halves. You can also take the differential and pop it together and make sure that it goes flush on both sides. That's when you know that the bearings are pressed in there far enough. And then just like the other one, we'll put the pinion gears in there, except for we'll put 2 of them in there. And then this one, you'll have a little lip and a groove. And the other one you can't put on backwards because the output's only on one side, but this one you can. You want to make sure that you're matching the lip to a groove and the lip to a groove. And then it will actually snap together. If you don't, you'll have a gap between the 2 halves of the case. So you just want to make sure that it sits flush on both sides. And then we'll screw it together and we'll make sure again that we're aligning the heads of the screws or marking the case with the metal gear on there. So that way we know for the next few steps which side the ring gear is on. So make sure you can see the metal part of the ring gear versus the plastic side. We'll put the head of the screws on the side with the ring gear. And then you can use your flat wrench to tighten them down. And as always, they don't need to be reefed down tight. They just need to be tight enough to prevent the case from opening up. So you can still rotate your gears. So this is why we want to know which side the ring gear is on. So we have our front axle and our rear axle. Our front axle, when we build the differential, has to have the ring gear on the right-hand side. And then the center differential has to have the ring gear on the left-hand side, and then has to have the ring gear back on the right-hand side. And if that's not set up that way, when we go to drive, one or more of your axles will want to rotate backwards while the other ones are rotating forwards. So we're going to get into the front axle assembly. So we will take the differential that we just built and we'll add the servos, the steering, the arms, and the wheel ends and the suspension to it. We'll basically build this twice, but with one of the differentials backwards, and as well as the middle axle. So we'll take our differential, and we're going to open up our driveline packs and our wheel end pack. So with our driveline pack, we want to get 2 of the 8 length drive lines, and then 4 of these pinion set screws. And then we'll want to pull 2 of the wheel end shafts from the wheel end bag. Then we use the 1/16 tool to go into the pinion set screws. And then it doesn't really matter which end of the drive line you put on the differential. I like to put this end on the differential. That way the larger end is towards the outside, but that's just a preference thing. So you'll have a larger hole and a smaller hole. You want to start this in the larger hole, and then it will thread itself in. And again, tighten it till it's tight, or the pin on the back side is flush with the face there. And then you can put in the wheel end there, do the same thing, place it in through the larger hole. And then just match that on the other side. We'll set that up to the side a little bit. We're going to grab our steering bracket and one of our axle housings, and then 4 of our 1.5 locks. These are the shortest little guys, and they don't have the big flange on the back side from the panel locks. And then again, if we hold on to the core of this, when we pop these in, then we can press the core in, and it will be locked into place. And then you can also take your mind's eye tool and not snap it in, but just use the end of the tool to rotate the connector, and that will actually cam it over on the back side, and that will prevent it from vibrating loose as well. So you can go through and cam over all of the connectors as you build them. And then we're going to get our steering bar and steering plate and 4 of the 3/8 screws. That will be in your steering bag. So we're going to put the plate on top of the bar, And then from the back side, we'll put the screws in through. And then when we're done, we want this bar to be able to easily slide back and forth. So if that means you have to back off some of the screws a tiny bit, just make sure that that bar actually can freely move from side to side. So you want the bar to still be able to easily move side to side. So we're gonna get our other axle housing piece, servo mounts, 2 transitions, and 4 3-locks. And this is a step where we need to make sure that when we're assembling this, we put the ring gear on the correct side. So it shows the orientation of the output as well as the side that the ring gear is on. So I like to line up the assembly we just made with the face of this. Two transitions. Two of our servo mounts. And then 4 of the 3-locks. So the 3-locks will be the wider ones, and it'll have the rib the whole length of the connector. Whereas the rotating ones, the 3 rotate will be the same length, just has the rib on just one part of it, of the 3 sections. So we'll take and make sure we built this with the head of the screw on the side of the ring gear, just like the picture shows, head of the screw on the side of the ring gear. We're going to sandwich this together. And then this side picture here shows that we want the output to be straight, because you can build this with it tipped at an angle, but we want it straight output. So we'll assemble this. Again, holding the core of the connector, we can pop this in, line up the servo mount, and the servo mounts have a rib on one side and no rib on the other. The side of the rib goes towards the outside so that the space for the servo is on the inside. And then the transitions, we want to make sure that we put them in there correctly as well. It shows them with the opposite or opposing side towards the outside. So we line that up, we want to make sure it's on the outside. And then we'll grab one of our servos. And then a little bag of hardware that comes with the servo. So in here, we're going to look for the 4 servo bushings and then the bushing sleeves. So you'll have some miscellaneous servo horns that we'll use later. And then you'll have the bushings and the sleeves, and then your hardware for screwing the servos down. So your bushing has a little tab on it That will key into the slot on here. So you make sure that that tab faces outwards towards the edge, otherwise it won't press in all the way. And you kind of have to just squish it in there. And then we'll want to put these sleeves, slide them in from the back side. So they'll be installed in from the back side. And what that'll do is when we tighten the screw down, it'll pinch that sleeve against the servo mount, and then the rubber bushing can kind of be a vibration isolation in there. So we're going to put the servo on, and we're going to make sure that we have the output of the servo on the correct side. In this case, it'll be on the right side. And then our screws with our washers. And these will be self-tapping screws. So again, like we did with the differential, you want to make sure that you're engaging the screwdriver in there well enough, and you don't want to strip out that screw. I like to line up one of them, get it started, then line up all of them, and then tighten them all down once they're all lined up and started. And these you can, as soon as you feel the screw stop up against that bushing, you can stop tightening it down. It doesn't need to be tight enough to crush the bushing underneath it, just until it touches it. Then we're going to grab one of our bags of shocks, some 12 beams, and then all the hardware out of the bags of shocks. So these should be the 12 beams. It's the one that has the most of it in there, but you can count the number of holes and make sure that it's the 12 beams. There's 13s, 15s, and 10s, 9s in there as well. And then for this kit, we will need more of these, and they will be located with the connectors at the end. So you'll have 4 of them with the shocks, but you'll need 2 more for each setup. So we'll take our washer, put it under the head of the screw, and then in the layout here, we're going to go a clearance one, which are the darker ones, through the beam, another clearance one, through the shock, another clearance one, through the beam, and then one of the interference ones, the lighter colored ones. And then in this case, on the left-hand side versus the right-hand side, we're going to go in 6 spaces, so we should have in the 6th one and then 6 open holes. So you can count 1, 2, 3, 4, 5, 6. So basically it's going to be just offset from halfway. And then we'll put that through the bottom of the shock. On the other side, make sure that they line up. And then if you hold the interference one in with your finger, you can tighten down this screw. And this will be another one where you don't need to reef it super tight, you just want it snug up against it so that it's sitting flush. So you want your shock to be able to still move. So that'll be one half of it, and we'll just mirror it on the other side. And it is not the end of the world if you get the spacings off by the tiniest bit. All right, and then we're going to assemble our wheel ends. And we're going to grab sets of the front wheel ends and the front wheel hubs. And if you're building this kit scratch out of the box, these will need to be assembled, but for the next year, this will already be snapped together. So you put one side in and line up the other side, and then pop it in, and then that allows it to rotate, but it won't come off. So if you can't find these as separate pieces, they'll likely be pre-assembled. And then we'll grab 4 of the bearings. And then pop in on the inside and the outside. And if you need to, you can oftentimes use either a drive line to press it all the way in, or like a nut driver to press it all the way down in there. And then we're going to get 4 of the 3 rotates and 4 more of the 12 beams. And again, the rotating ones will have the partial rib, not the whole rib. And then we're going to put the wheel ends on with the steering part facing towards you and the suspension attached on the inward side of the 6 spaces. So you should have mirrored set steering bar part facing upwards on the outsides. This should be on the inside, the 6 spaces on the outside on each. So we're going to slide them over the ends and then we'll attach them on. And it is important to make sure that all of these connectors are rotating connectors so that this can rotate freely up and down. If it's stuck, make sure that you've figured out which one of these is a locking connector and replace it with a rotating. And then out of the steering kit, we're going to get 5 of the 3/16 ball studs. That'll be these little guys here. And then we'll use our 1/16 tool, and this will go into the end of the ball stud. And then we'll use that to tighten these into the bottom 4 positions, and then the top, in this case from our point of view, left-hand side, the opposing side from where the servo is mounted. And then we want to make sure that when we put this top one on, we go opposite from where the servo horn is. And then we have steering rods here in the bag that says there are two sizes of steering rods. The shorter ones are for the front axle, the long ones are for the rear axle. So since we're building the front axle, we're going to look for the shorter of the two rods. If you can't tell in the bag, pull them both out of the bag. And line them up next to each other. And one is shorter, so we want the shorter set for the front. And then we want 4 of the 23mm ball cups, so they'll be the longer of the ball cups. And then we will thread these in. And then you want them both to line up the same so that they're flat with each other. And then we will snap them on to the bottom set of the ball studs. And then we will get the other size, the 16mm ball cups. They'll be the shorter ones, and then the center steering link bar here. And then from the servo horn sets, we want this steering servo horn. It is the shorter of the two, as well as one more ball stud. So in the picture here, it might be hard to see, but what we want when it's done is one of the ball cups to be facing down and one to be facing back. So when we tighten these together, we want to make sure that we get them adjusted in the correct orientation. So we want one where the cup is facing down and one where the cup is facing back. Then we can thread the ball stud into the end of the servo horn. And we'll snap the drag link onto the servo horn. And then we'll snap the drag link onto the steering bar. And then you'll have a servo horn on there, so we'll take that one off using the Phillips screwdriver to remove this servo screw. And then we're not going to tighten this completely on there. We'll do that on page 98. So we'll just take the screw and we're going to put the screw back in there, tight enough that it won't fall out, but still allows this to steer side to side without rotating the servo itself. And then we're going to take more of the 1.5s and the dual transitions. And we're going to attach these to the back side of the differential. And then we're going to get our little 2mm or 2.5mm dowels and the wheel nuts. And then in the end of these wheel shafts, there'll be a hole. We'll put the dowel through the hole. And then in the back side of the nut, there's a slot for the dowel. And that will actually clip onto there. And then that will be our front axle assembly done. So we can set this off to the side with our motor case and then build almost the exact same thing over again, except for this time when we build it, we're going to build it with the ring gear on the right-hand side as we're looking at it versus the left-hand side. All right, we're gonna do the middle axle next. So we'll take our dual differential and our drive lines and our wheel ends and U-joint set screws. And as before, we'll place it into the side with the larger hole, and then it will self-tap as you tighten it down. You don't have to tighten it too tight, just till it stops. The end of the pin should be flush with the back side. We get 2 transitions, our axle housing pieces, 2 two-beams, and 4 3-locks. And then for this one, there isn't an image as far as putting it on the right or left-hand side for the ring gear because we'll be able to rotate the whole assembly. There's no steering on one end versus the other. So we want the 2 beams sticking outwards. And these would be in place of, on the front and rear axle, the servo mounts. And then we'll make sure that the transitions are sticking with the tab part on the outside. Grab our last bag of shocks. More 12s. We need 2 more washers. So same as we did with the other ones, we're going to put the washer under the head of the screw, clearance adapter. We're going to put it in the 6th hole over. Another clearance adapter. Shock, clearance adapter, and then the interference threaded adapter. And then you want to make sure that this still pivots freely. And then we'll grab our 2 rear wheel hubs, 4 more 12 beams, 4 3 rotates, and then the 4 bearings. And we're going to place them in as we did before, and then put in the rotating connectors to hold them in place. So they should both be able to move freely up and down. We're going to get our dual transitions and then the 1.5s. Put them on. 8. then we get the 2 17mm ringlets and 2 of the 2.5mm dowels. Didn't snap in. So then that will be our middle differential. And then again, we have our reference here for the order that they go in: front, middle, rear, and then we'll start building the frame. So we're going to need 2 15 beams, 4 13 beams, and 4 12 beams, and then 8 two-locks. And then it labels them 12, 13, 15, 13, 12. So 4 12s. Two 15s. And 4 13s. So 15 goes in the middle, and then we'll have a 13 on either side of those. So then we're going to put this into the third hole on the 13, and then the end hole on the 15, and then do the mirrored on the opposite side. And then 2 12s, do the same thing, the third hole in on the 13, and then the end hole on the 12. And then the whole thing times 2. We should have 2 of those. And then the next step, we're going to attach the differentials, the axles to it. We want to make sure that we have the same layout as this: front, middle, and rear. So we're going to use 6 two-locks. And then I'm going to start with my middle differential. Seem to line that one up. this one in. And head of the screws goes on this side towards me. This should go in the center on the 15s. And then I have my rear axle. And this one will go 4 spaces in from the end. And then the front one, we'll do the same thing. It'll be 4 spaces between end and the end. And then if we have it flipped right side up, we can compare it to our picture here. So the ring gear should be on that side. So the head of the screw is on that side with the ring gear. The heads of the screws, the ring gear is on this side, as it's here. And then the head of the screw is on that side with the ring gear on that side. Then we're going to build 8 of these. So we need 8 9-beams, 8 dual transitions, and then 16 2-locks. I'm going to set the frame off to the side. So we'll find the 9 beams. So this should be the 9 beams here. And then these will go in the 3rd hole up for the bottom one. So that you have 1 hole at the bottom here below the dual transition. All right, then we're going to need to grab 12 of the 11 beams, and then 4 9 beams, 8 3 locks, and 16 2 locks. There's 4 9s. Then on here, we've got the front row will be 9s. So we use a 2 lock to hold a 9 on, then an 11, then another 11, and then we'll use one of these that we've made. So start with a 9 on either side of the axle. We'll do an 11 and that. So we'll do 2 lock ones, and then we'll do the 3 lock one. So we'll take our 9, we're going to attach it to the front end. And then an 11 will slide in between the axle and the steering. Another 11 will go right behind the axle. And then our beam with the dual transition that we added before, we'll use a 3 lock. And then we're going to put it in to the open hole in the frame rails we made. And then we're going to do that same thing on the other side and mirrored. And then in the center, we will do 9s and 11s. So we'll take the 3 lock through here, and that's going to go through the frame rails. And then our 11 with the 2 lock, it's going to go through the frame here on either side of the axle. And then mirroring it, 3 lock through the frame. So from front to back, we should have a 9, an 11, 11, a 9 with our attachment for the dual transition, a dual transition on a 9, and 11, and then mirrored as well. And I'm going to rotate it around so I can do the other side. So then the next step, we've got 16 two-locks, and these are going to go in place on here where the 11s cover the dual transitions on the axles. So there'll be 8 on either side. So those are here, 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 there, and there. And the next step, we'll use all 16 of the support arms and 16 two-locks. Now, with the support arms, you have the single hold side and the double hold side. You want to make sure that it's orientated correctly. And in this case, the double hold side goes out towards the end, and then the two-lock will go through the end hole there. So two-lock will go through the end hole, and then it's going to get placed onto the arm, and it's going to go into the hole just past the screw. So the screw will go into the other hole. And then we're going to do that top and bottom, front and back on both sets of axles. Then we're going to use 16 2 rotates on the other end, and these are going to go through the dual transitions into the single end of the support arms. All right, so if done correctly, all of these should still rotate up and down. And if they don't rotate, you'll want to double check and make sure that you're using rotating connectors and all of those that we just put on instead of locking connectors. We can set this to the side for a minute. And then we're going to grab the motor case that we assembled earlier without the encoder. So no encoder on it. We're going to grab 4 245 beams and then 4 3-locks. So 245 beams. And then these beams will be placed at an angle. So they'll go at 45-degree angles to each corner. And then we're going to get 8 transitions and 4 more 3-locks. And then these, we're going to make sure that the outside is up and out on each corner. And then same thing, mirrored and then mirrored. So we want the tab off to the outside. So it should look like this one's done. Up and out on all 4 corners. And we can set that to the side. We can grab the motor case with the encoder and do the same thing. And then same as we did before, 8 transitions, 4 3 locks. So we should have 2 motor cases that look the same, one without an encoder and one with. So then we're going to find our wires. One set of wires will come with the motor that we built for the motor case, and then the other set of wires will come in as a separate item with the encoder setup. So you can leave these attached to each other or you can separate them. It really just depends on, I like it cleaner with them connected to each other, but we're going to connect them to the back of the motors. So there'll be a red dot and we want to align the red wire with the red dot and slide the blade connector over top of the motor. On both of the motor cases. And then the encoder motor case, we're going to find our encoder wire. And this will be wrapped up like this. We're going to unwind it. And it will have one end with a white plug and then one end with 2 servo cable plugs. You're going to find the end with the white plug. And then when you connect it to the motor case, you want to look inside the connector. It'll have a series of pins. The pins will be on the lower edge. And then you want to look at the end of the plug itself and make sure that you're plugging it in the correct orientation, right side up versus upside down. There's 2 little tabs on the connector itself. Those should go down towards the PCB on the connector itself. So when you plug that in, you should have from left to right, orange, blue, brown, and then yellow. You can set that to the side. So the next step will be placing the drive lines in place and the motor cases. We're not going to attach the motor cases to make it easier to shift them forwards backwards to get the drive lines in. We're going to start with our encoder one, and on the far end, the back end, will be our yoke-to-yoke drive line. So that will be this one, our yoke-to-yoke one. So our yoke-to-yoke, our 2 1-length drive lines, and then our 3-length drive line. And then we're going to take our motor case with our encoder. We're going to put the 1-length one on there. And then we're going to attach this to that. And then we have our 3-length drive line. Goes on the other side. And it will be easier if you rotate the motor shaft so that the screws are visible from the side. Left or right side doesn't matter. We're going to grab our frame, and then the rear we're going to take this and slide it into place. I'm going to take the rear drive line and put it on the center differential first, and then I'm going to snake the front end down and snake that on. This is where you may need to rotate the drive lines to get them to line up with the holes in the differential outputs. So with that in place, I'm going to place the set screw on the yoke-to-yoke driveline on the front differential. You can place the U-joint pin on the tool and then slide it in from the side. And same thing, put it on there. And then we will slide it in and do the 3-link drive line to the middle differential. Set that back off to the side. And then we're going to do the same thing with this, except for both of the drive lines for the front motor case are the same length. So just as we did before, attach one. Attach the other. And then this one, we want to make sure that the motors face in towards each other. So we'll do the same thing as we did before. Snake it down in there. I'm going to try to line up my holes so that I can have access to them easier on the differentials themselves. And then we'll snake this one in. So now we've got our front axle, front motor case, middle axle, rear motor case with the encoder, and then the rear axle. And then these wires, you'll just kind of have to make sure that they stay out of the way but easily accessible as we continue the rest of the build. So I'm going to set this off to the side for a second. Then we'll use 8 of the 2 locks to attach the motor cases to the frame rails. And the motor cases can move a little bit forwards, backwards, but they will only line up with one set of the holes in the lower frame rails. And we'll set that back off to the side. And then we're going to build the upper frame rails. So we're going to need 15s and 12s. And we're going to need to do 2 of those. So 6 15s. and 4 12s. And we're going to need 8 2-locks. So this time we're going to put it in the 4th hole on this 15, and then line it up with the end hole on that 15. We'll mirror that to the other side. And then our 2 12s, we go 4th hole in, and then the end hole on the 12. 4th hole in, end hole on the 12. It should look like that. And then we're going to make another one. So we have 2 of those, and then we're going to place them in as the top rail of our frame. We're going to use 8 3-locks and 20 2-locks. So be careful, the 3-locks will go through where we have the vertical beams with the support arms and dual transitions attached. We'll also use the top of the motor case and the 11s and 9s. Not the 9s, just the 11s from before. So go through where our vertical beams with the support arms attached to them are. Go through 3. Have it offset by 1 hole. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more, roughly 2 locks to do. Flip it around and do the same thing on the other side. Then we're going to grab 12 of the 345 beams and 12 3-locks, and then we're going to put them on here at angles, and they will connect the tops of our 11 beams down to the open holes, mirrored front to back, left to right. So the 3s go through the bottom holes. We lift the top hole open for the next step. And then we're going to get 12 transitions and 12 3-locks, and we're going to place them through the top holes of the 345s that we just put in place. We'll rotate it around and do the same step on the other side. And then now we're going to take 13 beams and we're going to connect the tops of the shocks together across the axles. And we're going to use the 1 3/8 screws, washers, the shock mounts that were all in the shock kit bags. So we'll grab the beams. So to 613 beams. So we'll take a screw, washer, clearance adapter through the end hole on the beam, another clearance adapter. Then we're going to go through one of the shocks and then put the shock mount on place. And then we'll do another clearance adapter, another 13 beam, and then the interference thread adapter. And we'll thread this in place, flip it over and do it on the other side, and then do that for all 3 axles. And as before, when we tighten this up, we want to make sure that it's not crazy loose, but we want it to still rotate. So then we'll flip it over and we'll do the same thing. We'll stack those through on the other side. On this side, it's easier if you put the threaded adapters in the end of the beam first. Then we can take our screw and washer, and we can feed this through the one side into the shock, through the shock mount, and then thread it in. I'm going to flip this around because I am not left-handed. And then we will repeat that process for the other 2 axles.